So today we're going to be talking about rational equations. When you hear the word rational, you might want to think back to the first video that we did in this course. Rational meaning any number that can be written as a fraction. Also, if you see the word ratio, you might think the comparison of two quantities or the comparison of two integers. So as soon as I know that I'm dealing with some kind of fraction, if I want to combine any kind of fraction, I need a common denominator. That'll come into play today, as well as thinking of a fraction is really just the division of two quantities, which also leads me to think, okay, I'm dividing. What number am I never allowed to divide by in math or causes an error? Well, we cannot in math divide by 0. I'm going to write a note to myself for that, which also leads me to think, if I cannot divide by 0, well, what part of the fraction cannot equal 0? Well, it means that the denominator of your fraction cannot equal 0. So let me make up two examples to show you what I mean that the denominator cannot be 0. Sometimes fractional exponents can have denominators with variables, like 2 over x, or maybe 3 over x plus 4. What you need to think to yourself is, what value would cause this denominator to be 0 or for x to be 0? Well, in this case, if I plugged in 0 for x, that would be a problem. So x itself could not equal 0. In the second example, the denominator equals x plus 4. So some of you might look at that and say, okay, value that would make the denominator 0 would be negative 4. Some of you might do that in your head. If you're having trouble seeing where I got that, though, you could say that the denominator x plus 4, all of it cannot equal 0, and you could subtract 4 and get that x cannot equal negative 4. So this idea about checking to see what's possible at the beginning is going to be useful later when we're checking for something called extraneous solutions. So please just keep that in mind. So now before we go into solving these equations, we want to talk about the least common denominator. Some of you might think of that as a common denominator. Some of you might even think of that as the least common multiple. Let me show you what I mean by this on the next three examples. It's the simplest expression that every denominator is a factor of. So let's take a look at this example, number 1. We have three fractions, 1/3, 1/6, and 7/4, with denominators 3, 6, and 4. We want to figure out what the LCD is. Well, you can do it a couple different ways. You could think to yourself, what is the smallest number that 3, 6, and 4 are all a factor of? You could even think of it as, what is the smallest number that 3, 6, and 4 all multiply into? Well, either way, if you're thinking the answer of 12, I agree with you. Because 3, 6, and 4 are factors of 12, and 3, 6, and 4, 12 is the smallest number that they all multiply into. Now, something good to note is if I cross out 7/4 and I look at just these two fractions, LCD would no longer be 12, it would actually just be 6, because what is the smallest number that 3 and 6 both multiply into? 6. Now, life gets more fun when we deal with examples 2 and 3, when the denominators have variables. Now, because the definition of least common denominator does involve the word factor of, my eye goes to the denominator of fraction 1, x squared minus 9. I believe that itself could be factored. Numbers that multiply to be negative 9 and combine to be 0. X plus 3, x minus 3. We're still adding 5 over x plus 3. What I like to think about is, okay, I want to combine these fractions, or if I was asked to, they need a least common denominator or just a common denominator. This first fraction has an x plus 3 and an x minus 3, and the second fraction just has an x plus 3. What does it need to be the same as the first fraction? Well, it would need an x minus 3 on both top and bottom. That leads me to believe that my least common denominator, each fraction would need both an x plus 3 and an x minus 3. Now, x plus 3 and x minus 3 are each individual quantities. Both of them need the x, and the number is attached to the x in both situations. So you need x plus 3 and another x minus 3. If you wanted to think of it in terms of factors, you could ask yourself from the beginning, is x plus 3, x minus 3 a factor of itself? Yes. Is x plus 3 a factor of x plus 3, x minus 3? Yes, because x plus 3 is involved in both situations. Now, sometimes you might see the LCD not written in factored form, but rather multiplied or distributed out to get x squared minus 9. Both of these answers are fine. I'm guessing that a lot of teachers prefer the LCD is written in factored form. So what I'd like you to do with number 2 in mind is write down what you think that the LCD is for number 3. I'll be right back with you. My answer for the LCD for number 3 was that both fractions need the x minus 6 and the x plus 2. In other words, if you looked at this first fraction, it would need the x plus 2 on top and bottom. And if you looked at the second fraction, it would need the x minus 6 on top and bottom. So in order to combine those two together, you would need both, which is why I said that this was my final answer here. Again, just like number 2, LCD, you could multiply or FOIL out, get x squared minus 4x minus 12. As I said before, this is probably the more popular answer. Now into the meat of the lesson, solving rational equations. We're dealing with fractional equations. And before we even start finding the LCD, which is step number 1, I want you to ask yourself what value, if any, causes the denominator to be 0. Because if we get that value in the end, we might be in trouble. So I look at my 3 denominators, 4, x, and 1, and my eye goes to the x. Because x is in the denominator, I'm thinking that x cannot be 0. So if we get x is 0 later, we need to definitely double check ourselves. So if we want to think about the LCD in step 1, we have 3 denominators, 4x and technically 1. So each fraction would need a 4, an x, and a 1, which leads me to think that the least common denominator is going to be 4x. Step 2, we want to multiply each term the least common denominator. Let me show you what I mean by that. If I write down the original equation, we want to multiply the whole thing by least common denominator. And some of you might see why. If we distributed the 4x to every single term, some of you might see that the 4's would cross out the first situation, and the x's would cross out in the second situation, creating no denominators at all. For the visual learners, I'm going to go through all of it anyway, because it's good for notes. Give me a minute. I'm going to rewrite original equation with more space because I'm going to multiply every single term individually by 4x, the LCD. And if you want to be even more careful, you can multiply by 4x over 1. So if we go through each term individually here, if we do 4x times 1/4, 4's cancel out and we end up with just x or x over 1 minus. Multiply 4x times 14 over x, the x's cross out, and we're left with 4 times 14, or 56, equals. Now here, nothing crosses out, so we're left with 4x times 17, which would get us 68x. Here's the good news. Whenever we multiply by LCD, we create an equation that is now linear, meaning the highest exponent is 1. And solving equations like this to some of you is going to be great because you've been practicing it for a long time. So for instance, if we subtract x, we would get negative 56 equals 67. This looks fun. Divide by 67. And our lovely, glorious answer would be x equals negative 56/67. And we're confident on our algebra skills, we just got a gross answer. We still need to check for an extraneous solution. Remember, at the top, we said that the only value that x cannot be, or that would make the denominator 0, 0 itself. Did we get 0 for our answer? No, we got negative 56/67. So that passes the extraneous solution test. If you even want to, you could always take your value, plug it in for x, and see if both sides equal 17. That could work as well. I think we are in business. The answer is going to be negative 56/67. Now, what I'd like you to do is pause the video and think to yourself, is there another way I could have solved this equation? Or was there a way that you tried to solve? I'll be back with you in a few minutes with a couple of my ideas. But yeah, try to think of some on your own. Briefly, here were two other ways that I solved these equations. In way number one, I looked at the left side of the equation and said, what if I wanted to get a common denominator over here? Well, I multiplied the first fraction by x because that's what it needed to become 4x. And the second one I multiplied by 4 over 4 because that's what it needed to become denominator 4x. So I multiplied and got this step. Then I said both of them have a denominator of 4x, so I combined it to be one fraction. And since I had a fraction equaling another fraction, you can cross multiply and solve from x from there. So you could always pause the video and try that on your own as well. That's another option for you. And either other option would be using your calculator actually to find the point of intersection. Funny enough, whenever you have one piece of an equation equaling another piece, these two are considered separate equations in your calculator. You could come down here and y1 in your, if you're going to graph, you can plug in 1/4 minus 14 over x for y1 and 17 for y2, graph them both and see where they intersect. And that could get you a solution as well. If you have another way, I'd love to hear it in class tomorrow. So this is the last example we're going to do on this slide, or this video, but I am going to do another example after this as well for extra practice. I would highly consider doing it. So this example, again, I notice step 1, we have something that can be factored. So I'm going to rewrite the problem, 1 over x minus 2 plus 3 over x plus 3 equals 4 over, well, two numbers that multiply to be negative 6, combined to be 1, x plus 3, x minus 2. Ooh, this is awesome. This fraction has an x minus 2, this fraction has an x plus 3, and this fraction has an x plus 3 and an x minus 2, which leads me to think my least common denominator is that each fraction needs an x minus 2 and an x plus 3. So that is where I'm going to stop for a minute, and I just want to remind you of one thing. Our next step after finding the LCD is to multiply the entire equation by the LCD itself. X minus 2 and x plus 3. And you want to distribute that to every single term. Feel free to write it out. I want to give you a couple minutes to try this first and see how far you get. Remember, also feel free to check for what values cannot exist in the denominator. Let me give you a few minutes and I will check back in with you. Okay, so where I left you, we were starting to multiply the entire equation, the LCD. So what I did in the next step was in blue, I wrote the LCD 3 times, multiplied or distributed that out every single term, here, here, and here. And then in red, I crossed out what part of the LCD crossed out with the denominator. So from the first term, the x minus 2's crossed out, so I was left with 1 times x plus 3. The second term, the x plus 3's crossed out, so I was left with 3 times the quantity x minus 2. And in the third term, I had the x minus 2's and the x plus 3's cross out, so I was left with just positive 4, which left this equation to be completely linear, which is wonderful, again, because it's easier to solve. So I went through, distributed the 1, distributed the 3. When I finished solving everything, my final answer was x equals 7/4. So I said, okay, I trust my algebra. I want to go back up to the top or the original equation and ask myself, what values can x not be, if any? So I looked at the first denominator and said, okay, if the denominator is x minus 2, that means I can't equal 2, and I also can't equal negative 3. Since 7/4 does not equal 2 or negative 3, it is not extraneous, so I know that 7/4 is my answer. It's important to always check your work. Please go to the next video to see one more example.